Common ion effect. This is today's lesson. Let us see the matter in detail. Common ion effect. Electrolyte ammonium chloride. Ammonium chloride solution. Ammonium chloride is a kind of strong electrolyte. So, it ionizes fully to form ammonium ion and chloride ion. Again, another electrolyte, ammonium hydroxide. Solution of ammonium hydroxide. This is a kind of weak electrolyte. So, it ionizes partially to form ammonium ion and hydroxide ion. As ammonium hydroxide is a kind of weak electrolyte, it establishes equilibrium state with its ions. So, here we see that from two electrolytes, electrolyte ammonium chloride and electrolyte ammonium hydroxide. Ammonium chloride produces ammonium ion and chloride ion. On the other hand, ammonium hydroxide produces ammonium ion and hydroxide ion. Here, ammonium ion is common. Two electrolytes that produce same ion. This common ion is known as common ion. Now let us see effect of common ion, which is known as common ion effect. Now we are going to learn common ion effect. Suppose this is solution of ammonium hydroxide that ionizes partially to form ammonium ion and hydroxide ion. Solution of ammonium hydroxide. When solution of ammonium chloride is added to the solution of ammonium hydroxide, then from ammonium chloride solution we get ammonium ion and chloride ion. That is, concentration of ammonium ion increases in the solution after adding ammonium chloride, which contain common ion, ammonium ion. As concentration of ammonium ion increases, according to Le Chatelier's principle, this reversible reaction moves backward direction according to Le Chatelier's principle or equilibrium law. It means concentration of ammonium hydroxide increases due to common ion effect, ammonium ion. At one stage, ammonium hydroxide deposits as precipitate. That is, due to common ion effect, solubility of weak electrolyte is decreased. When solubility of weak electrolyte decreases, then this weak electrolyte forms precipitate. It happens due to common ion effect. Precipitation occurs due to common ion effect. Suppose this is solution of sodium chloride. Sodium chloride ionizes to sodium ion and chloride ion. When hydrochloric acid is added to this solution, then due to common ion effect, sodium chloride produces sodium ion and chloride ion. hydrochloric acid produces proton and chloride ion. Here common ion is chloride ion. So when hydrochloric acid is added to the solution of sodium chloride, due to common ion effect, sodium chloride crystallizes quickly. So here crystallization of sodium chloride occurs due to the common ion effect, chloride ion. Again, suppose this is solution of silver chloride. Silver chloride is a kind of weak electrolyte, so it establishes equilibrium state with its ions, silver ion and chloride ion. When solution of sodium chloride is added to the solution of silver chloride, then in the solution common ion is chloride ion. So due to common ion effect, concentration of chloride ion increases, and as a result, according to Le Chatelier's principle or equilibrium law, this reversible reaction moves backward direction. At one stage, silver chloride forms precipitate. Silver chloride deposits as precipitate in this beaker. So this precipitation occurs due to common ion effect. Suppose this is a mixed solution of copper sulfide and zinc sulfide, saturated solution. Copper sulfide ionizes to copper ion and sulfide ion. Similarly, zinc sulfide ionizes to zinc ion and sulfide ion. Saturated solution of copper sulfide and zinc sulfide. Here, solubility product of copper sulfide is 4.0 times 10 to the power minus 38. On the other hand, solubility product of zinc sulfide is 1.2 times 10 to the power minus 23. That is, solubility product of zinc sulfide is higher than copper sulfide. Solubility of zinc sulfide is higher than copper sulfide. This is point number 1. When in the solution hydrochloric acid is added, after that hydrogen sulfide gas is passed through the solution. Then let us see what happens. Hydrochloric acid, strong electrolyte, which ionizes to proton and chloride ion. Hydrogen sulfide, a kind of weak electrolyte. It establishes equilibrium state. It ionizes to proton and sulfide ion. Here, common ion is proton. Due to common ion effect, this reversible reaction proceeds backward direction. As a result, hydrogen sulfide produces less amount of sulfide ion. That is, in the solution, concentration of sulfide ion increases but it is less in amount due to this common ion effect. And as sulfide ion concentration increases, this reaction moves backward direction. At one stage, copper sulfide deposits as precipitate, but as solubility of zinc sulfide is higher than copper sulfide, ionic product of zinc sulfide cannot exceed solubility product of zinc sulfide. That is why zinc sulfide remains in the solution, but ionic product of copper sulfide exceeds solubility product of copper sulfide. That is why copper sulfide forms precipitate. It happens due to the common ion effect. Again, suppose this is mixed solution of aluminum hydroxide and zinc hydroxide. Aluminum hydroxide ionizes to aluminum ion and hydroxide ion. Zinc hydroxide ionizes to zinc ion and hydroxide ion. Here, solubility product of aluminum hydroxide is 3.7 times 10 to the power minus 15. On the other hand, solubility product of zinc hydroxide is 1.8 times 10 to the power minus 11. That is, solubility of zinc hydroxide is higher than aluminum hydroxide. From these values, we know solubility of zinc hydroxide is higher than aluminum hydroxide when solution of aluminum chloride is added to the solution and then ammonium hydroxide solution. Here, ammonium chloride is a kind of a strong electrolyte. It ionizes fully to form ammonium ion and chloride ion. On the other hand, ammonium hydroxide is a kind of weak electrolyte. It establishes equilibrium state with its ions, ammonium ion and hydroxide ion. Here, common ion is ammonium ion. Due to common ion effect, this reversible reaction moves backward direction according to La Chatelier's principle or according to equilibrium law, and as a result, concentration of hydroxide ion increases a bit. Concentration of hydroxide ion increases a bit, not very high. As a result, in the solution, due to increase of the concentration of hydroxide ion, both the reactions move backward direction. At one stage, ionic product of aluminum hydroxide exceeds solubility product of aluminum hydroxide, and for this reason, aluminum hydroxide deposits as precipitate, but as solubility of zinc hydroxide is higher than aluminum hydroxide, though reaction of zinc hydroxide moves backward direction, but ionic product of zinc hydroxide cannot exceed its solubility product. That is why zinc hydroxide remains in the solution, but aluminum hydroxide deposits as precipitate. This is all about common ion effect. Thank you very much.